future of aviation. It is the quietest and the most fuel-efficient narrow-body aircraft in the sky. And for us, the passengers, it is a dream. Why? Because there are no middle seats. It's a 2+2 configuration. No more fighting for an armrest with a stranger. On paper, this plane is a masterpiece of Brazilian engineering. It was supposed to be the giant killer, the plane that would make Boeing and Airbus nervous. It consumes 17% less fuel than the previous generation and has the most advanced fly-by-wire system in its class. But here is the mystery. Airlines are not buying it. While Airbus is celebrating hundreds of orders for its rival, the A380, the Embraer E2 is struggling to find a home. In the world of aviation, being the best doesn't always mean you win. Sometimes you can build the perfect machine, but the market simply refuses to take it. How can a plane that is so right be so wrong? Today we are going deep into the numbers. We are looking at why this tech shark is becoming a headache for investors instead of a gold mine. It's a story of great engines, bad timing, and very expensive legal trap. But first, hit the like and subscribe button. This simple action is vital for me. Thank you very much. The engine course. Innovation versus reliability. To understand why the E2 is struggling, we have to look under the wings. This is the Pratt & Whitney GFT, the geared turbofan. It is a technical miracle, but for many airlines it has become a nightmare. Here is the simple science. In a normal jet engine, the fan and the turbine spin at the same speed. But in the GFT, there is a gearbox. This allows the big fan at the front to spin slower, while the turbine inside spins much faster. This makes the engine incredibly quiet and saves nearly 20% on fuel. For an airline, that sounds like a license to print money. But here is the catch. This technology is extremely complex. The gearbox and the new materials inside the engines are under massive heat and pressure. In the first years of operation, this engine started showing teething problems. We are talking about hardware failures, cooling issues, and parts that wear out much faster than expected. Normally, you fix a part and the plane flies again. But today, the global supply chain is broken. There aren't enough spare parts. Now let's look at the mass. In the first year of a new aircraft's life, you expect it to be in the air 10 or 12 hours a day. But many E2 operators found their planes stuck on the ground for months, waiting for engine repairs. If we compare the E2 to the older E1 during their first years, the dispatch reliability, which is how often the plane is ready to fly on time, was significantly lower for the new model. Airlines hate uncertainty. When a CEO looks at the E2, they don't just see a fuel-efficient jet, they see a risk. They ask, will this plane fly tomorrow or will it sit in a hangar because of a broken gear? For many, the 20% fuel saving isn't worth a plane that cannot fly. The legal trap. How unions grounded a giant. But wait, if the engine is the only problem, Embraer could just fix it, right? Wrong. The biggest problem for the E2 is not mechanical. It is a legal trap called scope clauses. To understand this, we have to look at the United States, the biggest market for regional jets in the world. In the US, major airlines like United, Delta, and American don't fly their own small planes. Instead, they hire regional airlines to do it for them. But here is a very strict contrast between the big airlines and their pilot unions. This contrast is the scope clause. It says, you can use regional pilots, but only if the plane stays under a certain size and weight. There is one specific number that killed the E2. 76,000 pounds. That is the maximum takeoff weight, MTOW, allowed for regional jets in America. The older Embraer E175 fits this rule perfectly. It is the king of the US skies because it weighs exactly what the union allows. But the new E175 E2, because of those big heavy fuel-efficient engines and those advanced wings, It weighs nearly 89,000 pounds. It sounds crazy, doesn't it? Embraer built a plane that is better, cleaner and more quiet. But because of a piece of paper signed by lawyers and unions, it is too heavy to fly in the US. The unions refuse to change the weight limit. They want to protect the jobs of pilots who fly the bigger mainline jets. They fear that if they allow heavier regional planes, the big airlines will stop using large jets and replace them with smaller ones. Embraer made a massive gamble. They believed the rules would change by the time the E2 was ready. They were wrong. The rules stayed the same. And now the E175-E2, the most important version of the plane, has zero customers in the world's most profitable market. It is a tragedy of modern aviation. You can spend billions of dollars on engineering and create a masterpiece, but you can still be defeated by a single line of text in a legal contract. The shadow of Airbus, a David versus Goliath battle. Now imagine you are a CEO of a mid-sized airline. You need a new jet. You look at the Embraer E2, but then you look at its biggest rival, the Airbus A380. And this is where the shadow of the giant falls over Embraer. The A380 was not always an Airbus. It started as the Bombardier C series, a brilliant plane from Canada. But Bombardier almost went bankrupt building it. Airbus stepped in and used its massive global power to turn it into a superstar. How does Airbus win? It's simple. They are a one-stop shop. Airbus has deep pockets and a huge family of aircraft. When they talk to an airline like JetBlue or Delta, they don't just sell one plane. They can say, if you buy 50 of our big A321s, we will give you a massive discount on 20 small A220s. Embraer cannot do this. They are a smaller independent company. They have to make a profit on every single jet they sell. They cannot play the same money game as the giant like Airbus. The numbers tell a painful story. Airbus has over 800 orders for the A220. Embraer? They have around 200 for the E2. In the business world, success creates more success. Airlines see everyone else buying the A220, so they feel it is a safer investment. But there is one more secret weapon Airbus has – the pilots. If an airline already flies the Airbus A380, the most popular plane in the world, it is much easier to train their pilots to the A220. It feels like a part of the same family. If they buy the Embraer, they have to build a completely new department for training and maintenance. For many airlines, even if the Embraer is a slightly better technical machine, the Airbus is the better business decision. Embraer is fighting a war against a company that has more money, more influence, and a bigger family. It is a fight that is almost impossible to win. Global survival. Looking for a new home. So, is the E2 dead? Not exactly. Since the US market is blocked by legal rules and Europe is dominated by Airbus, Embraer is looking at the rest of the world. In places like Brazil, India, and Southeast Asia, the scope clause doesn't exist. These regions have thousands of islands and growing cities that need a plane exactly like the E2. Something bigger than a small turboprop, but smaller and cheaper to run than a massive Boeing 737. But the most important test is happening right now, in Canada, with Porter Airlines. Porter is the hero of the E2 story. They didn't just buy a few planes, they ordered up to 100 of them. They are using the E2 to fly long distances, like Toronto to Los Angeles or Florida. Porter is essentially a living laboratory. If Porter can prove that the E2 is reliable, that the engines stay healthy, and that passengers love the 2+2 seating, other airlines will stop being afraid. Porter is the advertising face that Embraer desperately needs. If Porter succeeds, the E2 survives. If Porter struggles, E2 may stay a niche aircraft forever. However, Embraer is smart. They are already preparing a plan B. They know the E2 might never be a global bestseller like the E1 was. So they are moving into a new space – sustainable aviation. While Boeing and Airbus are fighting over big jets, Embraer is designing a new generation of green planes. They are working on high-tech turboprops and even electric aircraft under their Energia project. Their strategy is simple. If you can't beat the giants in the jet market, lead the way in the green market. Embraer isn't giving up. They are looking for every gap in the market that the giants have missed. They are betting that the future of flying isn't just about being big. It's about being smart, efficient, and ready to pivot when the world changes. Now I want to ask you, would you prefer the Embraer E2 over Boeing or Airbus? And what do you think about this company in general? I'd be interested to hear your opinion. If you learned something new today, hitting the subscribe button is the best way to support me. As a new channel, every subscriber truly counts and motivates me to create better stories. Click here to watch the next video. Thanks for watching and see you next time. I found a weird abandoned version B787-3, and it was a real project, by the way. Could you imagine like 757 and 787 had a baby? It's literally what I've accidentally found surfing the internet. It is for sure a weird concept, because just why would you ever need a wide body which can fly only 5,000 miles? So today we will find this out. Actually, the intended range was even shorter. We are talking about a Dreamliner optimized for routes as short as 200 nautical miles. A specialized machine designed to act like a city bus, taking off and landing up to 10 times a day. This wasn't just a paper plane. It has 43 firm orders. It had a completely unique wing structure that looked nothing like the 787 we know today. And it was killed not by a crash, but by the concrete geometry of Japanese airports and the brutal physics of structural weight. In the next 15 minutes, we are going to dig into the hidden specification, the aerodynamic compromises, and the exact economic data that turned this plane into a ghost. But before we open the technical manuals, please hit this like button and subscribe to the channel if you enjoy deep engineering analysis. It helps me a lot. Now let's look at the numbers. Part 1. The anatomy of a mutant. To understand why this plane failed, we first need to understand what it actually was. Because from the outside, the fuselage of the 787-3 was identical to the standard 787-8. Same length, same composite barrel, same passenger capacity, but underneath the skin, it was a completely different animal. Let's look at the hidden numbers. The most critical difference was the MTOW, maximum takeoff weight. The standard 787-8 has an MTOW of roughly 228 tons. The 787-3, it was capped at just 165 tons. That is a 28% reduction. Why would Boeing deliberately cripple their own aircraft? Two reasons: landing fees and structural life. Airport fees are often calculated based on maximum certified weight. Airlines operating 45-minute flights would be paying long-haul prices for short hops. However, notice the MZFW, max zero fuel weight. It remained exactly the same as 161 tons. The 787-3 could carry the exact same heavy payload of passengers and cargo as the long-range version. It just couldn't carry the fuel to get them very far. It was a tank designed to be full of people, but empty of gas. But the real engineering crime, or innovation, depending on how you look at it, was the wing. The standard Dreamliner wing is the masterpiece of aerodynamics. It spans 60.1 meters and features those iconic racked wingtips. These sweep back to reduce drag during high-speed cruise at Mach 85. They are elegant, efficient, and huge. The 787-3 wing was chopped, literally. Boeing engineers reduced the span to 51.7 meters, and because they removed those efficient ranked tips, they had to bolt on massive vertical blended winglets, similar what you see on a 737 or 767. Now let's get into the physics. Why is a shorter wing a problem? It comes down to induced drag defined by this formula. Look at the denominator, b squared. That is your wingspan squared. Mathematically, cutting the wing from 60 meters to 52 meters theoretically increases induced drag by 25 to 30% for the same lift. This is why the 787-3 needed those vertical winglets. They weren't a stylistic choice. They were a necessary aerodynamic crutch, or fence, to stop high-pressure air from curling over the wingtip and destroying the lift efficiency entirely. So we have a heavy wide body with clipped wings, high drag and reduced fuel capacity. Why on earth did Boeing build this Frankenstein? The answer lies in the concrete geometry of two specific airports in Japan. Part 2. The Japanese trap and high cycle hull. The 787-3 wasn't designed strictly for the sky. It was designed for the ground. Specifically the concrete aprons of Tokyo Haneda and Osaka Itami. These aren't just airports. They are high-speed mass transit hubs. In Japan, domestic routes like Tokyo to Sapporo operate with high frequency of a subway line, often seeing 50 widebody flights a day. But there was a physical problem. The domestic terminals in Japan were built around ICAO Code D standards. This code limits aircraft wingspan to exactly 52 meters, the size of a Boeing 767-300 or the Airbus A380. If ANA or GAL tried to park a standard 787-8 with its 60-meter wingspan at these domestic gates, it would cause what is known as wingtip overlap. Essentially, one Dreamliner would block the gates on either side of it, creating dead zones. In an airport running at 99% capacity, losing two gates just to park one plane is an operational disaster. This is why the 787-3's wings were clipped to that magic number, 51.7 meters. It was the maximum amount of airplane you could physically fit into the parking slot. But filling into the gate was only half the battle. The mission profile was the other half. A standard long-haul aircraft flies for 12 hours, lands and resets. It performs one flight cycle per day. The 787-3 was built for high cycle operations. We are talking about flight times of 45 to 90 minutes, with turnarounds of just 30 minutes. It was expected to perform 8 to 10 takeoffs and landings every single day. This brutally accelerates wear and tear. To survive this, the 787-3 requires specific engineering changes that most people missed. First, the engines. It used the General Electric NX-1B54. Notice the number 54. This indicates a thrust rating of 53,000 pounds. The standard 787 engines produced 64 to 70,000 pounds. Boeing and General Electric deliberately derated the engines by roughly 16%. Why? Because in a high cycle environment, the enemy is heat. By limiting the max thrust via software, they lowered the turbine entry temperature, TET. This meant the internal turbine blades wouldn't melt or degrade as fast during those 10 daily takeoffs, significantly extending the engine's life between overhauls. Second, The brakes. Traditional hydraulic brakes get incredibly hot during landings and require cooling fans or long wait times before the plane can push back again. The 787 introduced electric brakes. These were a game changer for the 3 variant. They offered better thermal dissipation and allowed the aircraft to land, unload, load, and taxi out again without waiting for the brakes to cool down. It was the perfect machine for the perfect niche. A wide-body shuttle bus optimized for the unique constraints of Japan. So, with a perfect design and 43 orders from ANA and JAL, why did it die? The answer lies in what engineers call the terrible teens. Part 3. The economics of failure. The 787-3 didn't fail because of a design flaw. It failed because of obesity. In the aviation history, the first batch of 787s produced, line numbers 1 through 20, are infamously known as the terrible teens. Due to early struggles with manufacturing carbon fiber on such a massive scale, this aircraft came off the assembly line significantly overweight. Reports indicate these early frames were between 2.3 and 6.8 metric tons heavier than their target weight. For the long-haul 787-8, this weight penalty was a nuance. It meant the airline just had to carry a little less cargo or fly significantly shorter routes. It was manageable. But for the 787-3, this was a death sentence. Remember, the 787-3 used the exact same fuselage structure. It inherited all that excess structural weight. On a 10-hour flight, the fuel efficiency of the 787's engines eventually pays off. But on a 45-minute hop, you are spending the entire flight burning fuel just to lift the heavy composite structure into the air, only to land immediately. The composite advantage completely evaporated. Let's look at the CASM, cost per available seat mile. This is the only number that matters to an airline CEO. When analysts run the numbers of a heavy 787-3 against a mature, cheap-to-buy Airbus A380-300, the 787-3 offered perhaps 8 to 10% better fuel efficiency on short routes. But its ownership, costs, the monthly lease payments, and insurance for a brand new high-tech jet were nearly 30% higher than the older Airbus. For a regional carrier, the small fuel saving could never pay the massive price tag of the plane. Then the timeline collapsed. The entire Dreamliner program was years behind schedule. Japan Airlines, one of the 2 key customers, entered bankruptcy protection in 2010. They needed a reliable airplanes immediately, not experimental prototypes that were overweight and years late. They realized the standard 787-8, while not optimized for their gates, was at least going to be built. They converted their orders to the long-haul version. With the Japanese anchor customers gone, Boeing looked around for other buyers. British Airways for Heathrow, United for US hubs, they all said no. The capital cost was simply too high for a short-range plane. In December 2010, Boeing quietly removed the 787-3 from its price list. The project was dead. But here is the twist. Today, 15 years later, the weight problems are fixed. The 787 is lighter, stronger, and better. So, could the 787-3 actually work now? Part 4. Revival and the what-if scenario. With the 787 program now mature and the weight issues long gone, could Boeing bring this plane back today? Technically, yes. In fact, if they built a 787-3X, today it would be a beast. We now have the technology that was considered science fiction in 2004. Folding wingtips. Instead of chopping the wing and destroying the aerodynamics, a modern 787-3 could simply fold its tips. It would have the full efficient 60-meter span in the air to save fuel, and then fold to 52 meters on the ground to fit into the tight gates at Haneda or Heathrow. It solves every problem the original had. But it will never happen. And the reason isn't technical, it is the rise of the super narrow body. Since 2010, the market has fundamentally shifted. Aircraft like the Airbus A380 and the Boeing 737 MAX 10 have changed the mass. These are single-aisle planes that can now carry up to 240 passengers. Compare the economics. To fly a wide-body 787-3 on a short route, you are dragging a massive heavy fuselage designed for 2 aisles and cargo containers that you might not even feel. To fly a 737 MAX 10 on the same route, you carry almost 80% of the same passenger load, but with a trip cost that is roughly 40% lower. The efficiency of modern narrow bodies has cannibalized the market for short-range widebodies. Unless an airport is so incredibly slot-constrained that you need to squeeze every single human possible into one departure slot, the widebody just doesn't make financial sense. The niche that the 787-3 tried to fill simply doesn't exist anymore. The Boeing 787-3 remains one of aviation's most fascinating what-ifs. It was a scalpel designed for a very specific surgery, but between the manufacturing delays, the weight penalties, and the shift in market, the patient died before the surgery could even begin. Its legacy, however, lives on. The high-cycle engines and electric brakes developed for this ghost plane are now standard on the 787-10, which ANA and United use today as the spiritual successor to the plane that never was. The 787-3 proved that in aviation you can't just fight gravity, you also have to fight the accounting department. And usually, the accountants win. Thanks for watching. If you enjoyed this deep dive, press the like and subscribe button. Fly safe and see you in the next one. Look at this plane, the Boeing 777X. It is a masterpiece of engineering, with its massive folding wingtips and the largest jet engines in history. It was supposed to be the new king of the skies. It was built to replace the legendary 747 and change aviation forever. But there is a problem, a big one. Instead of carrying passengers around the world, these giants are sitting in a hangar, gathering dust. Why? Because in August 2024, the dream turned into a nightmare. It happened during a routine inspection. Engineers were checking the test planes after the flight in Hawaii. They weren't expecting to find anything serious, but then they saw it, a crack. This wasn't just a scratch on the paint. The crack was found in a critical part called the thrust link, a heavy metal component that helps attach those massive engines to the wing. Immediately, Boeing had to make a tough call. Ground the entire test fleet. No more flying, no more testing. Everything stopped. This isn't just another delay in a project that is already 5 years late. This is a major structural failure. So how did the most advanced plane in the world end up broken on the ground? Let's dive into the disaster. Anatomy of a breakdown. When you hear cracked structure, you probably imagine a wing snapping in half like a dry twig. Thankfully, that is not what happened there. The carbon fiber wings themselves are fine. The problem is hidden under the wing, right where the engine connects to the plane. The broken part is called a thrust link. Think of it in this way. The engine is a monster that generates incredible power to pull the plane forward. It needs a very strong connection to transfer that power to the body of the aircraft. That connection is the thrust link. It acts like a massive titanium joint or a heavy-duty arm. Its only job is to push the plane throughout the air. So, here is the scary question. If this link breaks in the sky, does the engine fall off? The short answer is no. Aviation safety is built on a principle called redundancy. If one part fails, another part is ready to catch the load. The engine has multiple attachment points, so even with a snapped thrust link, the engine would stay on the wing and the pilots could land safely. But don't relax just yet. While the engine won't fall off, this is still a catastrophe for Boeing. Why? Because this is a brand new plane. Heavy metal parts usually crack after 20 years of flying, not during a few test flights. This is what engineers call a structural failure. It means the calculations were wrong. Either the metal material was too weak, or the vibrations from the engine were much stronger than Boeing expected. And you cannot fix bad mass with tape. You have to redesign the solution. The curse of GE9X engines. To understand why parts are cracking, we need to look at the beast causing all the stress. Meet the General Electric GE9X. This is not just an engine, it's a monster. It's officially the largest jet engine in history. To give you an idea of the scale, the front fan is so wide that you could fit the entire body of the Boeing 737 inside it. Yes, you heard that right. A whole other plane fits inside this engine. But is it possible to be too powerful? The problems with the GE9X didn't start in 2024. The curse began back in 2019, before the 777X even took its first flight. During ground testing, engineers noticed something alarming. The compressor blades inside the engines were wearing out incredibly fast. They were overheating and deteriorating. Essentially, the engine was hurting itself just by running. General Electric had to redesign these complex parts, which delayed the first flight for a long time. Now, seeing the structural cracks in 2024, it raises a difficult question. Is this engine simply too strong for the plane? It feels like the 777X is operating on the absolute edge of what is physically possible, and the stress is tearing it apart. Innovation or unnecessary risks. But the engine isn't the only thing pushing the limits of physics. Let's look at the wings. To make the 777X efficient, Boeing gave it a massive wingspan of over 71 meters. These long, slender wings are great for aerodynamics. They create amazing lift and save a lot of fuel. But there is a practical problem. The plane is simply too wide. It physically cannot fit into standard airport gates. So Boeing came up with a radical solution. They added a hinge. It is the first commercial jet in the world with folding wingtips. After the plane lands, the pilot flips a switch, and the ends of the wings, about 3.5 meters of them, fold up vertically. It looks like a transformer robot. This clever trick allows this giant to park in the same spots as smaller aircraft. It is an engineering marvel. But ask any mechanic, the more moving parts you have, the more things can break. This mechanism requires complex latches, locks and heavy pins to keep the wings straight during flight. If you look at the recent cracks in the engine mounts, you have to wonder about the wings too. By adding this folding system, did Boeing introduce yet another point of failure? It is a brilliant innovation, but in a project already plagued by structural issues, complexity is a dangerous game. The shadow of the predecessor. Now we have to address the elephant in the room, the ghost that haunts Boeing. When people hear about these problems, they immediately ask one question: is this the next 737 MAX? It is a fair question. The tragedies of the 737 MAX destroyed Boeing's reputation. People became afraid to fly. But it is important to understand that these are two very different situations. The 737 MAX disaster was caused by a software. A hidden computer program called MCAS pushed the plane's nose down, and pilots couldn't fight it. It was a digital trap. The 777X problem is different. It is not software, it is hardware. It is metal and physics. A structural failure like a cracked truss link is a classic mechanical issue. In a way, this is better, because you can see it, touch it and fix it, before anyone gets hurt. However, there is a deeper problem that links both planes: trust. The crack in the 777X was found after the plane had already flown for over 100 hours. Critics argue that this points to the same old problem at Boeing: a broken safety culture. Is the company still trying to rush production? Are they cutting corners to save money? When a passenger steps onto a plane, they don't care if the problem is software or hardware. They just want to know that the company built it right. And right now, Boeing is struggling to prove that they still know how to do that. The economics divide. While engineers try to fix the metal, Boeing's accountants are facing a different kind of a disaster. Time is money, and the 777X is burning billions of dollars. The airlines that ordered this plane are running out of patience. Take Emirates, for example. They are the biggest customer for the 777X. Their president, Tim Clark, has been waiting for this jet since 2020. He isn't just annoyed, he is furious. He has openly criticized Boeing, calling the delays unacceptable. When your most loyal customers start shouting at you in public, you know you are in trouble. But the real danger isn't just angry words, it is the competition. While the 777X sits broken in a hangar, its rival is already flying high above it. The Airbus A380. The Airbus might be slightly smaller, but it has one huge advantage: it works. It is reliable, efficient and available right now. Airlines hate uncertainty. They need to plan their schedules years in advance. Why would they wait for a maybe from Boeing when they can buy a guarantee from Airbus? If the 777X doesn't fly soon, it risks arriving at the party after everyone has already gone home. By 2027, will anyone still need this plane? Or will the Airbus A380 have already won the war? So the final question remains: when will you actually be able to buy a ticket? The original plan was 2020. That deadline is ancient history. Right now, the most optimistic forecast is 2027. And even that depends on how fast they can redesign the broken parts and convince the regulators. But when it finally arrives at your airport gate, should you be afraid to step inside? Here is the ironic truth: this disaster might actually make the plane safer. The FAA regulators are under immense pressure. They aren't going to sign any papers until they are 100% sure. They are watching Boeing like a hawk. Every crack, every vibration and every bolt is being analyzed with a microscope. Because of these delays and failures, the 777X is going through the toughest certification process in aviation history. Paradoxically, By the time it carries passengers, it might be the most tested and verified aircraft ever built. It has the potential to be the safest king of the skies, if Boeing can survive long enough to finally get it off the ground. So, I have to ask, would you feel safe flying on the 777X in 2027? Or would you stick to Airbus? Let me know in the comments. If you enjoyed this video, please consider subscribing. This is a new channel, but I put a lot of effort into every video to make it clear, accurate and worth your time. Now check out this video next. I think you will find it fascinating. Thanks for watching and see you in the sky. In a world where airlines fight for every drop of fuel and retire planes after just 15 years, these giants are dinosaurs. The MD-11 is loud, dirty and incredibly thirsty for fuel. Passenger airlines gave up on this play way back in the early 2000s. But look at the night sky. It is still swarming with them. Why do the richest logistic companies in the world still cling to technology from the 1980s? The answer lies in the mass. It goes against all common sense, but it makes billions of dollars. But first, hit the like and subscribe button. This simple action is vital for me. Thank you very much. Mathematics. Capital expenditures versus fuel. Wait, doesn't an old plane like this burn money every time it flies? Let's look at the real difference between owning a plane and flying it. If you wanna buy a brand new Boeing 777 freighter today, the official price is around $352 million. In reality, after negotiations, airlines pay about $160 to $170 million. That is still a huge amount of money. Now let's look at the MD-11. FedEx and UPS were smart. They bought these used planes from passenger airlines for peanuts, maybe $10 or $20 million each. Then they spent about $15 million to convert them into cargo planes. The final price for a ready-to-fly MD-11? Only $25 to $35 million. For the price of just one shiny new Boeing 777, you can buy a fleet of 5 or 6 MD-11s. But what about the gas? It is true, the MD-11 is thirsty. It burns about 20 to 25% more fuel than a modern jet. That is roughly 8,000 kilograms of fuel per hour compared to 6,000 kilograms in a 777. However, unless oil prices explode to $150 a barrel, that extra fuel cost simply doesn't matter. Today, with oil sitting comfortably around $60 or $70, the math is even better. The massive amount of money you save on buying the plane easily covers the fuel bill for years. As they say in the airline business, the best plane is the plane with no monthly payments. The lazy plane factor. Utilization. So why doesn't this math work for passenger airlines? Why doesn't KLM fly old cheap planes? It is because the business models are completely different. To pay for itself, a modern jet must be in the sky for 14 to 16 hours every day. When you fly that much, saving fuel is the most important thing in the world. But cargo is a different game. The life of a FedEx MD-11 is actually very lazy. It usually flies a short trip at night to a major hub, like Memphis or Louisville. It sits on the ground all day long while packages are sorted. Finally, it flies back the next night. In total, it might only fly for 3 to 6 hours a day. Here's the logic. You cannot buy a new Boeing 777 for $170 million and let it sit on a concrete for 18 hours a day. That is a huge amount of frozen money, doing absolutely nothing. But for a cheap older plane, that is fine. If the job involves a lot of waiting on the ground, the cheap MD-11 is actually the perfect machine. The golden mean niche. Load capacity. You might ask, why not just use a different old plane? Well, the MD-11 survives because it has a unique superpower – its size. It fits into a perfect niche that no other older plane can fill. Let's look at the alternatives. First, you have the Boeing 767-300 freighter. It is a great plane, but it can only carry about 53 to 58 tons. For long flights between continents, that is often just too small. On the other side, you have the legendary Boeing 747-400, the jumbo jet. It is a monster that can lift 113 to 120 tons. But here's the problem. Flying a 4-engine giant that is only half full is incredibly expensive. It is overkill. This is where the MD-11 hits the absolute sweet spot. It carries roughly 85 to 92 tons. It holds significantly more cargo than the smaller 767, but it is much cheaper to operate than the massive 747. For specific high-volume routes, like Anchorage to Tokyo or Cologne to Louisville, the MD-11 is not too big and not too small. It is just right. Engineering hell and hole number 2. But it is not all good news. The accountants love this plane. The mechanics absolutely hate it. The biggest headache is the number 2 engine, the one stuck right in the tail. Unlike the engines under the wings, you cannot just walk up to this one. It sits extremely high off the ground. Mechanics need special high-lift platforms just to reach it. Changing an engine on the wing is a standard job, but changing the tail engine is a logistical nightmare. It takes much longer and requires way more effort. And the worst part – spare parts. Remember, McDonnell Douglas disappeared in 1997. No one is manufacturing new parts for this plane anymore. So how do FedEx and UPS keep them flying? They have to cannibalize other planes. They buy old retired MD-11s just to strip them for parts, like vultures. It is the only way to keep the fleet alive. Pilot killer or diva? If the mechanics hate the MD-11, the pilots, well, they respect it, but they also fear it. Some call it the diva, others have darker nicknames. The reason is simple. This plane does not forgive mistakes. Statistically, the MD-11 has a higher accident rate during landings than almost any other modern wide-body jet. You might remember the tragic crashes of FedEx Flight 80 in Narita or Lufthansa Flight 8460 in Riyadh. Both happened right at the moment of landing. Why is it so difficult to land? It comes down to physics. To save fuel and reduce drag, engineers made the horizontal stabilizer, the tail of the plane, smaller than usual. While this made the plane efficient, it also made it less stable. To keep this heavy beast in the air with such a small tail, you have to fly fast. The landing speed, or VREF, is incredibly high, often around 150 to 160 knots, almost 300 km per hour. This is 20 to 30 km per hour faster than similar planes. Everything happens much quicker for the pilots. To help with stability, there is a computer system called LSAS. It is supposed to assign the pilots, but sometimes it behaves unpredictably, fighting against their inputs. The biggest danger is a bounce. If a pilot hits the runway a little too hard, the plane can bounce back into the air. If they try to push the nose down too quickly to fix it, the plane can enter a violent cycle called porpoising. In the worst cases, the nose gear collapses and the plane flips over on its back. It is a powerful machine, but it demands absolute perfection every time it touches the ground. The end of an era. However, nothing lasts forever. The end is finally coming. FedEx has officially announced the beginning of the end. By the year of 2028, they plan to retire their fleet. They are replacing these old warriors with the smaller Boeing 767 for shorter routes and the massive Boeing 777 for the long hauls. But here is the surprise. They are not killing the MD-11 because of fuel prices. The real killer is maintenance costs. As these planes get older, the engines break down more often. When a plane is stuck in a hangar for repairs, it loses money. Eventually, the cost of fixing it becomes higher than the money you save by owning it. Now I want to ask you, Do you miss the era of trijets, or do you prefer the efficiency of modern twin jets? Write your thoughts below. If you learned something new today, hitting the subscribe button is the best way to support me. As a new channel, every subscriber truly counts and motivates me to create better stories. Click here to watch the next video. Thanks for watching and see you next time. For the last 20 years, the strategy in the Middle East was simple. Copy Emirates. Every airline wanted the biggest planes, the massive hubs, and millions of transit passengers. Just look at Dubai. It is an absolute giant. You see endless rows of the Airbus A380s and terminals packed with people. It is impressive, sure, but let's be honest, it is also chaotic and stressful. Now look at this. This is Muscat. It is calm. It is beautiful. Just a modern Boeing 787 waiting at the gate. While its neighbors are still fighting to be the biggest superconnector, Oman Air has decided to stop the race. They said enough. Instead of copying the giant, they are building the anti-Emirates. Today we are going to look at why Oman Air is shrinking its fleet and why becoming smaller might be the smartest move in aviation in 2026. But first, hit the like and subscribe button. This simple action is vital for me. Thank you very much. The superconnector trap. To understand Oman Air's new plan, we first need to look at the giants next door. For a long time, the aviation world in the Middle East was defined by Emirates, Qatar Airways and Etihad. Their model is legendary. Build a massive airport in the desert, buy hundreds of wide-body planes, and connect the entire world through one single hub. It works perfectly for Dubai and Doha, but for everyone else, it is a dangerous trap. Just look at Etihad Airways in Abu Dhabi. A few years ago, they tried to grow too fast. They wanted to catch up with Emirates at any cost. The result was a disaster. They lost billions of dollars and almost went bankrupt. Oman Air was heading down the exact same path. For years, they tried to be a major transit hub. They wanted to funnel millions of passengers through Muscat, just like their neighbors. But the math didn't work. The airline was losing money consistently. They were burning cash just to keep up with the competition. Finally, the leadership realized a hard truth. The market is full. To survive, Oman Air didn't need to get bigger. They need to stop copying the giants and find their own way. The boutique philosophy. So what is the solution? Oman Air calls it the boutique airline strategy. The goal was simple. Get passengers to fly through Muscat to reach London, Bangkok or Sydney. Oman was just a transfer point. But that era is over. Now the focus has shifted from transit to destination. They want to bring tourists to Oman, not just move them across the map. This means they are no longer chasing numbers. They don't want to carry millions of passengers who are just looking for the cheapest economy ticket. Instead, they are focusing on quality. They want the premium traveler who values comfort over house. Think of it like the hotel industry. Emirates is like a massive 5-star mega resort with 3,000 rooms. It is impressive, but it is crowded and you are just one of thousands of guests. Oman Air wants to be the exclusive boutique hotel with only 50 rooms. It is quiet, personal and curated. They are proving that you don't need to be the biggest to be the best. One world, the secret weapon. So how do you survive as a small airline surrounded by sharks? The answer is simple. You don't fight alone. This is the biggest difference between Oman Air and Emirates. Emirates is famous for doing everything by itself. They don't join alliances. They rely only on their own fleet. But Oman Air knows it cannot win that way. In 2025, they made a game-changing move. They officially joined to the One World Alliance. This is their secret weapon. Suddenly, Oman Air doesn't need to buy hundreds of planes to reach the world. By joining the alliance, they instantly gained access to over 1,000 destinations. They can now sell you a ticket to almost anywhere on the planet. using their partners' networks. For years, Qatar was the fierce rival next door. But now, because they are both in one world, the former enemies are partners. Instead of fighting a price war for every single passenger, they can now cooperate. It is a brilliant strategy. Stop the expensive war and start sharing the profits. Optimization over scale. To make this new strategy work, Oman Air had to make some tough choices about their hardware. First, they decided to kill the Airbus A380 fleet. These planes served them well, but they are older and less efficient. In the new boutique era, every drop of fuel counts. Instead, they are betting everything on the Boeing 787 Dreamliner. This is the perfect tool for their mission. Unlike the massive A380, which needs 500 passengers just to break even, the Dreamliner is smaller and lighter. It allows Oman Air to fly long distances on thin routes. Routes that are profitable, but simply does not have enough people to fill a giant double-decker plane. For shorter flights, especially to connect with India and neighboring countries, they rely on the 737 MAX. It is efficient and does the job perfectly. But the biggest change is inside the cabin. You won't find first class on their new planes. Oman Air realized that flying empty first-class suites is a waste of money. Instead, they introduced the Business Studio. This is a super business class. It offers the privacy and luxury of first class, but at a price point that makes sense. It is smart luxury, not wasteful luxury. The airport experience. If you have ever transferred through Dubai, you know the struggle. You land, you wait for a train between terminals, you walk for 20 minutes, and you stand in endless lines. It is loud, crowded, and stressful. Honestly, it often feels more like a giant shopping mall than an airport. Muscat offers the complete opposite. It is a definition of stress-free. The new terminal in Muscat is designed for speed and comfort. Everything is under one roof. You can walk from your arrival gate to your departure gate in just a few minutes. There are no trains to catch and no marathon walks to endure. The design reflects the country itself. While Dubai screams busy and expensive, Muscat is calm and welcoming. It uses natural light, quiet spaces, and elegant architecture. It turns the worst part of travel, the layover, into a moment of relaxation. For a passenger tired after a long flight, silence is the ultimate luxury. The anti-Dubai destination. An airline is always a mirror of its country. Just as Oman Air is the opposite of the Emirates, the country of Oman is the opposite of Dubai. Dubai is famous of having the tallest skyscrapers, artificial islands, and endless hype. It is impressive, but it often feels man-made. Oman is completely different. It is the anti-Dubai. Here, instead of glass towers, you see jagged mountains. Instead of giant shopping malls, you see ancient forts and traditional markets. It offers an authentic Arabian experience, not a theme park. Oman Air uses this difference to its advantage. They don't just want you to change planes, they want you to step outside. That is why they heavily promote their stopover program. They allow passengers to stay in the country for a few days at no extra flight cost. It is a clever deal. Why spend your layover sleeping in an airport chair when you could be exploring the mountains? So will this bold strategy actually work? It is definitely a risk. In the business world, we are usually taught that growth is good. Shrinking your airline to make more money sounds a bit crazy. However, Oman Air is betting that quality wins over quantity. By flying fewer planes and focusing on higher-paying passengers, they hope to finally become profitable after years of losses. In a world where flying often feels like taking a crowded bus with wings, Oman Air is trying to bring back a sense of exclusivity. They realized they cannot beat Emirates at their own game, so they simply stopped playing it. They do not want to be the biggest airline on the planet. They just want to be the best airline for their niche. Now I want to ask you, what would you choose for your next trip? A quick, quiet transfer in Muscat or the shopping and bright lights of Dubai? Let me know in the comments below. If you learned something new today, hitting the subscribe button is the best way to support me. As a new channel, every subscriber truly counts and motivates me to create better stories. Click here to watch